Hey Greg, question for you. Does it look like the ephemeral sharding PR is in working order at this point? Sorry, not sharding, ephemeral pinning.
It's not an octopus. There's another update to it. I haven't looked at it yet to see if we're in good shape or not.
Okay, just wanted to get an idea if it was. Are we backporting that to octopus, or is that going to go in just after?
We probably will backport to a point release once it's ready, but
Okay,
we'll have to see.
okay. All right, looks like we are starting to get people streaming in here. I see Igor now, so maybe Core is wrapping up. Uh, so I will get this started. All right. New PRs this week, or actually the past 2 weeks. Uh, we have one that changes the locking in Blue Store, and that makes me really nervous. But they showed nice looking performance improvements with it. I think Kifu and Igor both have looked at it at this point. I will attempt to take a look at it as well, but I think it's it's a little tricky. So, Igor, I think you had mentioned that you were concerned about it as well. What were you concerned about?
Well, I like the idea behind this patch, which is to reduce the global lock lifespan
Hmm.
and introduce per writer and maybe per file locking. But I'm not sure if it's easily doable with current design or some. I'm afraid we need to revise this code significantly to introduce fixes like that.
I think
So
so
I'm not
too.
sure it's enough reliable enough.
I don't feel confident in my ability to actually convince myself that changing the locking that way is okay. But I guess I would trust if you and Sage think it is, then I guess I would trust your opinion. But it fills me with a little bit of dread.
Well, at least I put a note in my uh, records maybe to take a look at the overall design here. Maybe we can um, we can get some benefits from the idea.
Sure. Okay, so the other new PR that I saw anyway was just a replacement of the previous column family sharding PRs from Adam. He kind of tied them all together into one new one. So that's 34006 and closed for the last 2 weeks. There's a nice PR from Haumai to use pinnable slice to avoid an extra copy from RocksDB. That's really nice. I need to take a look at that a little closer, but that potentially is I've seen situations where I think that's going to help a lot. So I'm excited about that. Um, and then there was some kind of optimization for the NVMe device here with the queue size of controller ops. I have no idea what that does, but anyway, let's see. Oh, and then the other three are Adam's old column family sharding PRs that all got cleaned up. All right, two PRs updated that I saw this week, both from Igor, the deferred big rights PR, and then the hybrid allocator PR, which we I think spoke about last time in this meeting. Those are getting reviews, updates, testing. So I think just kind of moving along, but not quite ready yet. All right. So the only specific discussion topic I have for this week is that our RGW and perf and scale DFG team were tracking down what we thought was an issue in Beast, the Beast backend for RGW. They were seeing this performance drop after a certain amount of time, a fairly significant one. And after lots and lots of work by Mark Hogan on their team, they found out that it was not, in fact, RGW. It was behavior kind of induced by the OSD. So what appeared to be happening is that the OSD was going along doing its work and filling up the cache, fine. And at some point we hit the cache limit. Okay, that's normal, right? And we don't have an infinite amount of cache. And so at that point, the memory auto-tuning on the OSD started trying to balance between the block cache and the O-node cache because we now started doing O-node reads from disk. In master right now, when that happens, we unfortunately end up populating almost the entire block cache and O-node cache with O-nodes because it's kind of like a hierarchical thing. So there's a PR we have that works around that fixes that, 27705, but it requires an on-disk format change. So we haven't merged it yet. We've kind of waited until Adam's column family sharding PR gets in so that we can just do one on-disk change, once for users, but get both benefits at the same time. So in any event, okay, we start doing reads from disk, populating it into the block cache, but they started seeing the page cache on the node start going up because those reads are happening using buffered I/O. They're buffered reads. The reason that is because at one point about 2 years ago, we changed BlueFS buffered I/O to be on by default rather than off. So, okay, normally that's not bad. It's actually kind of desirable because then RocksDB can kind of use the page cache as a secondary cache rather than just only getting the benefit of doing reads from the block cache. So normally that seems like it's been a performance win. But what happened in this case is apparently as the page cache was filling up, at some point the kernel decided to start digging into swap. And that is the point at which they started seeing performance really tank on the node, and significantly. It wasn't just like a little bit. It was like from what I recall, it was like a 5x reduction or something like that. It was really bad. That I haven't looked at some of the information that they had, or I don't know if they actually gathered information on what was being, what faults were happening. I wonder, or I'm a little suspicious if it's possible the Ceph process itself was being swapped out. But in any event, it wasn't good. So 27705, the PR that fixes double caching, I assume would probably help in this case because it would mean that we don't basically shrink the O-node cache to start giving memory to the block cache and seeing the total amount of cache, both of them being consumed by O-nodes, and then the block cache not having stuff for compaction in it. So then we are faulting and doing reads to disk, and it's horrible. I think that PR would help. I don't think it would fix it because at some point we would do the exact same thing when we ran out of cache anyway. It'd just be farther out. So at some point we're going to start doing reads from disk on a real cluster somewhere. Normally the kernel should not cause this kind of horrible swapping behavior, I wouldn't think. But in this case, for whatever reason, it did. And that's not something that we are going to be able to easily control. So I think the answer here is that we go back and disable BlueFS buffered I/O. It's kind of a shame because then we can't use the page cache for RocksDB SST file reads. And Sage had made a note that in the original PR to enable this, that he thought it was beneficial for the compressed case for BlueStore reads of compressed data. But I don't know that we ever tested that, so I don't know if it's actually true or not, or if it's just kind of a thought that we had. Good news, I think, is that we probably want to head this direction anyway. If we can do direct IO reads everywhere, because we're going to be doing that on NVMe devices anyway, it might actually be faster in some circumstances if the kernel is not involved. Or well, it's involved, but less involved, I guess. And then for containers, we aren't going to probably have swap anyway, which I guess maybe we wouldn't have the problem then, but it's just kind of probably better overall for us to be trying to do a good job of doing everything ourselves in our own caches and kind of getting as close as we can to that container memory limit without going over it. So, not using the page cache as a crutch is maybe a good thing. So anyway, that's kind of it. Comments, concerns? What do people think? And I saw you put a note in here. Little slower, I guess, right? For disabling it.
Or at first, or like after a few hours of run, and then when he ran it for a longer run, he said it ceased to be measurable.
Okay. Yeah, I think the kind of nebulous benefit of maybe being better for compression and potentially reading from page cache when the block cache is full doesn't seem worth it to me.
It only has a pathological result in our case.
Yeah. Sorry, Josh, what were you going to say?
I was just going to say, yeah, I agree. It's not worth trading off stability for a tiny bit of potential marginal gain somewhere else that we haven't even measured.
Yeah. And personally, I just kind of want to get the kernel as much out of the picture anyway. So it's more of a philosophical thing than anything. But
so our design idea, right, is to bypass pitching, right, into.
Yeah, I mean, it feels like every single time we involve the kernel in some way, at some point we hit some kind of weird issue that we can't easily work around without just getting it out of there in the first place. I mean, we hit it with inodes sometimes, we hit it with other memory VFS layer stuff, we hit it with this, or we hit it with other things. It's just if we could fix things in the kernel easier, maybe that would be better, but I don't know. That's just been my experience personally, I guess. So, all right. I think I have not heard any concerns with doing this. So, Josh, do you know, have we already created a PR for this, or I can make one quick if there isn't one?
I don't think there's one yet.
Okay.
So if you want to go ahead, that'd be great.
Yeah, I'll just make one quick for this then. Cool. All right.
Thanks a lot
That's
for
all
your
I've
help
got.
on this one, Mark.
Oh, I didn't do much. Mark Kogan was the one that did everything.
Just understand it, and that was very useful. Because what Mark figured out how to do was just drop cache, just drop the page cache. More subtle, more required knowledge. It most certainly is affecting other people. So I think that's the win here.
Yeah. Okay. What else, guys? Anyone have anything this week that they'd like to talk about?
I suppose we can mention the CDS next week. If you want to talk about any performance topics there, please add them to the CDS specific pad. I'll post it in the chat here in a minute.
Josh, do you want to, should we cancel this meeting? Is it going to overlap with some of the CephFS stuff?
Let's see.
I'm going to move that session.
Greg, you were robot-y. What was that?
You're going to move the CephFS session, so it won't overlap?
Yes. Yeah,
Oh, okay.
I'm gonna put it at either 6 or 7 Pacific time because hopefully we'll get some of the guys from India there, and it's a little late for them.
Okay. Do we keep this then, Josh, or do we make this part of it, or how do you want to do that?
Yeah, if we want to talk about maybe the performance CI stuff more, we could list this in the pad too as another aspect we'll discuss at the regular performance meeting time. Does that make sense to you?
Yeah, that's fine. We can talk about that. Trying to think what else would be good. Oh, I suppose one thing that I did want to maybe bring up today, and I don't know if it's worth bringing up with this or not, is that as part of this disabling of the BlueFS buffered IO, we should figure out when we can get 27705 in. I don't know where the column family sharding is at right now, if that's really getting close to merging or not, but we should get that in. We should try to get Igor's onode shrinking PR in as well.
Yeah, I think the column family charting is pretty close as well. I got Adam's now running through the Rados and RTW suites, and it's passing. So I think it just needs a bit of review.
Okay. Are we going to backport that with the first point release, or is that not? What's going on with it?
It sounds like the first point release maybe next week, so we probably wouldn't backport it that soon. But
Okay.
probably after that.
Okay. Yeah, I'm trying to think about how to get the 27705 layered on top of it, and then kind of get those in at the same time if possible.
Yeah, I think that'd be ideal.
And maybe Igor's stuff too, if we could get his onode shrinking PR in at that same time. I mean, it doesn't need to be, I guess, but it'd be really nice if we could kind of tie those together, because they should result in some compounding, memory reduction.
Mm-hmm.
And then we can just kind of generally list that as a feature of that point release. Igor, how do you remember with that PR? Is there anything that still needs to be done, or does it just need to be tested?
I think no. Maybe some rebase needed, but in other aspects it look pretty ready.
Okay. Josh, do we just need to run that through Teuthology once it's rebased? Is that kind of the last thing we need to do for it?
Yeah, I think so.
Okay. Cool. I can do that.
So in fact, we'll need batch it into master and then backport to Octopus, right?
Yeah, exactly.
Yep. Cool. Okay. So I guess, yeah, there's probably not a whole lot that we need to discuss with that for next week. Then we can just get that done and do the work on it. Okay, other than performance CI, Josh, is there anything else for CDM that would be good to discuss, do you think?
I think maybe this time slot works pretty well for booster discussions. So if there's anything else we want to talk about for booster improvements, that'd be a good time to do that.
Sure.
Like maybe, for example, it might be worth testing IOUing booster again. Currently in backward to CentOS 8.2 now, and it sounds like it's in much more stable shape these days than it was previously. It'd be interesting to see how it does.
Is CentOS 8.2, has that been released?
I'm not sure yet.
It looks like Red Hat 8.2 beta has been released.
Okay, well, we can probably test with that.
Yeah, although it'd be a lot easier to test with CentOS on the Incerta or Officinalis nodes. Okay, but yeah, this is good, especially if it's going to get that soon. Then I think you're right. IOU ring would be good to test. We merged that too, didn't we?
Yeah, we did. I'm not sure
Yeah,
if we did a lot of extensive testing after that point, though.
I don't think so. that that whole kind of bit of code surrounding our how we do AIO and p-read and p-write and an IOU ring is all kind of a little gross. I mean, it's okay, but you might want to consider the whole structure of that bit in Blue Store.
I haven't looked
If I
at the black
remember
codes
right,
too much myself.
if I remember right, it's been a while since I looked at that PR, but I think it basically like piggybacks on top of the libIO code and kind of abuses it a little bit. But I mean, it works.
Kind of shoehorns
But
it into the same model instead of using the IOU model more directly, you mean?
yeah, or at least the um the AIO class. I think it's basically kind of like reusing it, sort of, um, and it works, right? But it's not super straightforward.
Sure.
Okay, yeah, that sounds good. So, all right, Performance CI, IOU ring. I think there's stuff I'm interested in regarding the CephFS MDS, but I don't think I'm ready to talk about it yet for next week. So maybe punt on that.
Any other Blue Store improvements that we should think about for Pacific Ewer?
I mean, we've talked about most of the stuff in this meeting. I think that that's coming. That's good. I mean, Adam's stuff is going to help with column family sharding. The new allocator code from Igor and all of his other code. That's all going to be, I think, a really good improvement. Oh, once we get both Adam's column family sharding in and then my the double caching PR in. After that, I can layer the age binning, the cache age binning on top of that, which would be, I think that's kind of what's we need that other piece in there before we do the age binning. So that can also go in. I don't know if it's interesting to talk about or not, but there's that.
Yeah. I mean, some of these things that maybe aren't so much need of discussion, but it's just worthwhile to organize them and plan out the sequence of
Sure.
what we're going to do.
Okay. Yeah. Anything else from anyone else? All right. So one other thing, I guess, that I forgot about that maybe we could talk about this week since Ilya is here. Ilya, so background on this, on Cephfs and kernel RBD, so kernel Cephfs and kernel RBD, I was seeing a fairly large throughput bottleneck for sequential reads from a single client. And after lots of testing with Ilya, what it appears to be is that there's kind of a limit to the I/O depth that you can hit with a single kernel, I guess. We don't see scaling across multiple kernel RBD volumes on one client node. And we also see an actual degradation in performance as you increase the I/O depth on one volume, with it peaking somewhere around, I think it was 64 IOs, concurrent IOs. We saw somewhat different behavior when doing NBD. Within one volume, we saw it didn't scale well, but then when you had multiple NBD volumes, it did scale well. And when you used either librd or libcephs directly, everything was great. We got significantly higher performance. So I went and ran a bunch of metrics while this was happening, and the only thing that I really noticed myself was that once we got above an I/O depth of 64, then in the kernel, we started seeing memory copy taking more time in the kernel worker threads. It wasn't like a ton. It was like maybe 1% CPU time in each one of those threads, but it really consistently showed up when the performance started going down. So that was the only thing I noticed. Iliad, do you have any comments, or were you able to see anything beyond what kind of I saw in those results?
No, not really. I mean, the memory copies are kind of expected because with the increased queue depth, you're just pushing out more data through the stack. And so memory copy showing up at around 1% is, I guess it's fine, although I haven't tried to reproduce it myself to see if it shows up on, just on a regular virtual machine instead of a very beefy node that you have. One thing that looked odd to me is that there were only a couple kernel threads showing up in that perf trace, but if you had, I think at one point you said you had 80 OSDs. Maybe the rebuilt cluster had some other number, but it's still it's still more than a couple, and there should be for a sequential workload with that queue depth, I think there should be like more kernel threads active and showing up in that in perf. So that's the only thing that looked kind of out of place to me. I looked at the IO stat numbers, and I mean they confirmed that even though we maintain the queue depth and we maintain the IO sizes, the IOPS number drops and the throughput therefore also drops. The other thing that looked odd is the default queue depth for RBD devices is 128, and so your test where you ran it with 256, that showed even worse performance compared to 128, but that shouldn't have been the case because the FIO would just sit on those IOs and not being able to push them to the device driver. And so I would expect, or I would have expected the performance to be the same for 128 and 256. So, but those are just tiny pieces of like inconsistencies, but they don't explain the slowdown, obviously. That's beyond that. I don't have anything to add.
Okay. I don't. So I have not figured out how to do this yet, and maybe you know or somebody else knows. Is there any way to get good, like, lock profiling inside the kernel to figure out if it's possible. Like you had mentioned that not seeing lots of kernel worker threads. Is it possible if there's some lock that things are waiting on and we only see a couple at once in this scenario?
Well, there shouldn't be. But one thing you can do is, I'm not sure if log debugging is actually enabled in the kernels that I guess you're using upstream CentOS kernels, and so it might be disabled. But there is a thing called logstat, which is a file in /proc, which if log debugging is enabled, it dumps out a table with all kernel logs, and there are, with columns like how many times this log was acquired, how many times it contended on acquisition, read or write, stuff like that, and it sorts them by in the order that you'd expect. So if you just do cat /proc/logstat and pipe it to head, you will see the most contended logs, and there's also wait time in there as well. So one thing that might be useful is to get that. I'm not sure if it's enabled again, but see if it's enabled, and if it is, gather those results for the QDEPs. I guess we can concentrate on 32, 64, and 128 now, since the rest are more or less noise. There's some stuff that you can do with perf, but that's more complicated and requires a lot of manual steps. But getting the logstat file up to the workload runs should be enough, as long as you reboot between the runs. Yeah, and if it is disabled on the CentOS kernel, then we can definitely do a build using our Jenkins with it. I think it might be enabled in the in the testing branch that we built in Jenkins. So one option might be to just grab that kernel.
Okay. Yeah, sorry, I was kind of chuckling earlier when you mentioned rebooting. Our aficionados knows take about 30 minutes to 60 minutes to reboot, which is unfortunate.
Yeah, well, you would only reboot the client node, right? So it's it would still take the same amount of time, but it's only only one node. It's just that I don't remember, or I can't remember if that file can be cleared, or so if those stats can be reset. It might be that you can actually do something like echo clear to that file, but I'm not sure. Probably not.
Sure.
Because you can do that with some other stats files in the kernel, but the logstat thing is I think you can't.
Okay. Beyond locking, is there anything else that's worth looking at that might help kind of explain what we're seeing?
Well, general networking stack stats might be useful, but again, I think locking would be a good step, and then see, because I keep going back to the bonding versus non-bonding issue, which is how this whole thing started. Because if it only shows up in a particular networking stack configuration, then there's nothing we can do at the libsaf layer, and no amount of lock optimization or anything like that will help. So that's why I was going to try to see if it shows up just because a Q depth of 64 is I mean we test that in Tethology. We just don't time it, but if the performance difference is this noticeable, then it should be noticeable on just on a regular virtual machine or even on a regular Smithy node. So I was going to try to do that.
I don't.
But yeah, this is just to mess around. So I don't expect to get anything out of that. But I would like to see numbers regarding, like, with regards to the networking stack, because it just seems that maybe there is like something that we're doing wrong, because obviously like librd with the same networking stack is able to push much more data through, but it just seems weird to me that it hasn't come up before, because that code hasn't changed in a long time. So either people are just not doing this type of workloads, or no one has noticed, which is kind of unlikely.
So I just linked the original results. These are the ones from way back that started this whole thing. And it did look like for kernel RBD that we did see decent, well, not great, but decent 4 megabyte reads across all of the nodes when we were in the bonded configuration. We didn't necessarily for CephFS. So is there anything that could possibly result in a situation where if you're trying to spread your reads across multiple network interfaces, that it would be slower, even though it's not like we're only going at one. I went back and verified it's actually spreading it out across all four. Is there anything there where we could be in some kind of weird state where we can only write to one or read from one at once or something? Would we be involved in that, or would that be somewhere else in the kernel?
Yeah, I don't think libceph, the libceph layer is involved in any way. The interface would get picked by the kernel, and all we're doing is just receive message calls in this case.
Sure.
It's the same function that the system call calls, just with a couple of layers stripped down, or stripped out. There are some security checks omitted. That's about it. So that the fact that librd that we don't see this with librd is kind of puzzling. But looking at this, like looking at line, what is it, line 3 in this document that you linked, it clearly shows that RBD kernel, even with XFS on top, which is not the same as bare librd, it showed like 62,000 compared to 15,000 with individual. That's why I sort of I'm a bit like skeptical of going down the road of doing extensive log profiling with perf. Well, we might see something in the networking stack, but it won't be at libceph. And
sure.
Obviously, this would be much harder to fix in the networking stack because we don't control.
Yeah. each worker is doing a receive?
Well, this is organized as a work queue, and that might actually be something to look at, because the work queue management code is doing some. I mean, yeah, but at a high level, it is organized as, you can think of it as a kernel thread that is doing a receive message, and there is a single lock per connection. So basically, per that thread, that lock is there just to protect against, if the session gets closed underneath the underneath the messenger and things like that. So that lock is not involved in actual I/O, should not be contended on it. But this is organized not as a set of kernel threads, like one for each session, but as a work queue. And so I guess technically you could get into a situation where there aren't enough work queue threads, and so we don't schedule enough work items, and not enough receive message calls. So that might actually be something to look at. But again, this does not explain the difference between the bonded versus individual cases, because it's the same code doing the same thing.
Is it how many work queue threads do we have?
That's what I was stressing, that it's not a set of kernel threads. It's a set of work queue, worker threads, and that's completely dynamic. So the kernel has a pool which it reuses with other workers. So these workers are not private to the messenger work queue. They're global, and the kernel does whatever to ensure fairness. And
how many threads are in that pool?
Again, that's unspecified.
Oh, we don't know.
Yes, but in general, it should be. I mean, we don't bound it in the messenger, so it is in theory, it is if you have, I think there's over 100 CPUs on that system, so there should be plenty of them.
It scales with the number of CPUs?
Well, there can be more worker threads than CPUs, but obviously only the number of CPUs kind of limits the concurrency, and the work queue management code takes the number of CPUs into account. But it will spawn more worker threads than there are CPUs, simply because some of them can be blocked, and but it does take the number of CPUs into account.
Okay. And so when we have work being done by one of those threads, is that, sorry, I might be repeating myself here, but that's where we do the receive message?
Yes, the receive message happens at the in the work queue worker thread, and we don't block, so we're doing this asynchronously. So if there is not enough data, we just back off, and we finish the work, and this thread can get reused by another session, another connection for another receive message, or go to some other work queue in the kernel. So we don't block them.
Okay, so but receive message itself, is that asynchronous or is that synchronous?
the receive message itself is synchronous, but we invoke it with the don't wait flag. And so if there's not enough data, it just returns immediately. But if it needs to read data, this mem copy, which we're saying, that happens, under the receive message call in the stack.
Okay. So theoretically, if, like you said, there wasn't enough data, it would just return immediately, and it'd be, kind of non-blocking sort of. But potentially, it could block if there was some other thing it was doing that it was waiting for, and it thought it could proceed, right?
No. So it doesn't.
Oh.
It doesn't block. It just, my point, in saying that it's synchronous, my point was that it takes. It can take time simply because one of the things it does is obviously a mem copy into the socket buffers, but it won't block, as in it won't sleep waiting for something. If it needs to wait for something, it will unroll the stack, return, and we will move on and wait for a notification that more data to read is available.
So
and once we get go ahead.
I was going to say the reason I asked that is because in IO submit, theoretically that's non-blocking as well, right? It just returns, but in reality, sometimes it's slow enough that it takes time, right?
Well, the IO submit is the IO submit is kind of a. I don't think it's the kernel. I think up until very recently, it was explicitly documented that IO submit can block in some cases. Because some because this has to do with the file system code, not with the because a random file system, whichever one you're using, can end up needing to do work either due to the fact that something was not quite aligned, even though the IO that you submit is aligned, but something within the file system can end up unaligned, or there is some metadata stuff that needs to be done, and there was a bunch of work done in the I think in the recent maybe 1 or 2 years to get it truly non-blocking, so that it never blocks and always returns immediately. But that required changes. Not to the, I guess a little bit of changes to the AIO, IO submit infrastructure, but a lot more changes to the individual file systems. And at least at one point, the situation was that IO submit, became non-blocking on XFS, but would still block in some cases on the ext4. Or vice versa. So it's always been kind of a little bit of a race between the major file systems to get to the point where the system calls that are expected by everyone to be non-blocking, so that there actually are in all cases.
Sure.
But
so you don't think there's any cases where receive message in the kernel would potentially do something where it could be waiting or waiting for something else to complete before it actually completes itself?
No, not off the top of my head.
Okay. Okay.
But yeah, again, I can go into the to the difference between bonded and non-bonded, because this whole work queue management code and how we call receive message becomes completely irrelevant unless there is unless the network stack is doing something really weird, because I would have actually expected a problem with the bonded mode and not with the individual interfaces, because
yeah.
I would think that the bonded mode is like it's a lot less people do it than just, here are some interfaces, go use them. And I would have expected the individual interfaces case to perform better and the bonding case suck. But when it's the other way around, yeah, I really don't have an explanation for it.
Yeah, I hear you. And the fact that it works fine with things from user space too, right? That's bizarre.
Yeah.
And then the IO depth piece. I still wonder if it's possible we're seeing two overlapping things here, or if it's really just one big thing. But yeah.
Well, the IO depth is, on the one hand, it's kind of what you'd expect if you're pushing kind of more data. It like exposes some kind of an issue. That much is expected. But it's just like the numbers are not very consistent, and that's something that I would expect from like a 10 node, 10 volume, whatever setup. But when you're doing this on an isolated node with no SD on it, and it's a single volume and a single FIO process, and we're still seeing like the 256 case, which should be exactly the same as 128, because exactly the same amount of data goes through the networking stack. But in the latest email that you sent out, the biggest difference was actually between the 128 and 256 cases. That was the biggest drop. And there shouldn't have been any because that's the same number of IOs of the same size. So there's definitely something like weird going on, but it's not just, it might very well be a combination of several things because I just don't see like the problem with 128 versus 256. That would point to at the block layer or much higher in the stack than the networking stack. But then the problem, like the difference between bonded and non-bonded, and the amount of data pushed between the QDepth 32 and QDepth 64, because you basically double it on every test. That points to the networking stack, and so things just sound consistent between the ones.
There's one case I think is I'd like to ask you about. I just linked some of these other tests in the chat window here. The NBD case on a single volume, I guess not a single volume, but on one volume per node, and then increasing the number of processes in that volume. So essentially increasing the QDepth by virtue of having more processes. NBD follows kind of the behavior of the kernel RBD pretty closely. It's low when kernel RBD is low, and sort of higher. It doesn't work as well, but it's sort of higher when our kernel RBD is higher. But then in the multi-volume cases, that's where it's fine. It does really well. Does that tell us anything?
The NBD numbers is the other piece that doesn't make sense, and that's why I was asking you. That's why I was asking you about missing librrbd numbers to compare, because
those are in there now, by the way.
Like this is like all over the place. I mean, the numbers they don't fit into like a consistent there's no explanation that I was able to come up with, because I've stared at these graphs for I think like well, definitely over like 30 minutes just at this graph, considering all the like looking at each, like trying to match them up in like different ways, but I'm afraid to say that I failed.
That's okay. I fail on a regular basis. Okay, so it sounds to me like then my next step is I will try to go and look at the locking information and see if that tells us anything.
Yeah, the locking information, it might be worth to maybe do some perf magic. And since this is now in a single node and can potentially sort of get like more supervision as opposed to running it completely automatically, perhaps we could do some like take some perf snapshots to see like what the CPUs are doing in general, because it didn't look like the CPUs are not loaded at all, or at least it looked that way from the perf record that you pasted.
Yeah, for large
And
sequential reads, we shouldn't be loading them real heavy.
right, but the fact that like some of them need to be like with each QDAP step, like with doubling up QDAP, there is like more and more copying that each CPU needs to do, and we should just generally be seeing CPUs like a lot more than a couple doing work in the K workers that have Ceph in their name. And if they're doing something else or not doing or do nothing, that's obviously a problem.
Okay.
Because assuming a somewhat random distribution of like which object goes to which OSD with a QDAP of 64, that should be, I don't know, at least like 25 OSDs involved at a time. At least 25.
Oh, yeah.
Yeah, at least 25 key workers doing something with the stack trace that has Ceph in it, because otherwise the system is misbehaving, and we need to figure out how.
All right. Well, we're out of time here, I guess. But go ahead.
Yeah. So I was just saying, like, set something up that just runs some perf commands like every minute or every 30 seconds or something like that, depending on how long the entire test takes, so that we have a reasonable number of snapshots to look at and compare.
Sure. Yeah, we can easily do that. Right now, that little script that I wrote just runs perf the whole time, right? But it could just run it, periodically, I guess, and then sleep or something.
Yeah, something like that.
Yeah. And then quickly before we wrap this up, I suspect that this will not show up in on the Smithy nodes or anywhere else. I didn't see this with our Inserta nodes. The low performance mark here that I think we've seen is something like 2.5 gigabytes per second, right? That's faster than the networking on Inserta. Inserta usually maxes out somewhere around there. Even though they're 40 gig links, I typically don't see it go that much faster than that. So even if this was going on, if it's some kind of even if it was happening on like a single interface, if we take out the whole bonding versus networking out of the picture, we still probably wouldn't have seen it on any of those.
Can we boot this node with just a single networking interface and do the same test and see if if it how fast are those NICs?
There are two NICs. Each NIC is on a separate NUMA node, and each has two 25 gigabit ports.
Could it be a NUMA problem? Could it be that the kernel is doing something weird with the NUMA assignment, and that the user space just happens to do right because the OSD does whatever NUMA magic and it inherits it from?
So the outgoing route should be over whatever interface is associated with the remote subnet, right? So each of those interfaces is on a separate subnet, and then each OSD is on a particular interface associated with one of those subnets so that it's all balanced. Does that make sense?
Okay.
So assuming that the kernel is doing the right thing, it should be picking whatever OSD we need to talk to. It should go out that interface is associated with the subnet that remote OSD is on. And we do see it properly going over, like balancing across interfaces. So it looks like that's happening correctly. It's choosing the one that it should go out through and not just going out through one or something.
Well, I'm still wondering if booting with just one of these NICs and trying that out, because just one NIC should be enough to go over 2 gigabytes, right? And so that this shows up.
Yeah.
So maybe that's actually that should be like a quick thing to try, like without gathering any additional data, and just see if it shows up.
Yeah. Do we need to disable the NIC, or would it be enough to just effectively disable it by not having any traffic go out of it? The other card.
Well, that I'm not sure. It's probably better to just completely shut it off with. Because again, we don't know where the problem is. I'm just trying to isolate, and isolating by shutting something off entirely as opposed to just kind of sort of disabling it is always better to just pull the plug.
I'm trying to think about what the most effective way to do that is. I mean, I might be able to disable the PCI slot in the BIOS itself on all the on that host, on that particular host. Maybe can you pass kernel parameters via boot parameters to disable a specific device?
You might be able to. I've never done this with networking interfaces, but I do this routinely with CPUs and memory. So in order to test something with low memory, I just boot with parameters that says So there might be something for networking interfaces as well, but I'm not sure. I've never done.
Okay. All right. Well, I do have to run here. Thank you, Ilya. I really appreciate it. I really appreciate the help.
Well, thank you for the investigation.
Yeah. All right. Well, have a good day, guys. Have a good week. See you again next week, and hopefully we'll know more next time.
Bye.
Yep. Have a good day. Bye.